Ndugu mtazamaji wa kipindi chetu cha Safiri Salama na Merikebu, somo la leo mtaalamu wetu ametuandalia linaitwa Ocean Current. Hasa Ocean Current ni nini? Basi ndugu mtazamaji, tunaomba karibu sana uangalie kipindi chetu. Karibu.
Good morning once again. My name is Captain Konsi Mgawe from Azam Marine. Welcome once again to Safiri Salama na Merikebu, and today we have a different subject. Previously we had a class on ship construction and stresses. We discussed some stresses and the constructional sequence of a general cargo as a Steadicus. But today we're going to discuss something different slightly, but also pertaining to the sea. It's about ocean currents. By definition, an ocean current simply means it's a general horizontal movement. It's a general horizontal movement of a body of seawater, because we say ocean current, a body of seawater on either permanent, semi-permanent, or seasonal basis. An ocean current is a general horizontal movement of a body of seawater on either permanent, semi-permanent, or seasonal basis. What causes ocean currents? Ocean currents can either be caused by geodetic scale of the earth, which means one side being higher than the other one. For example, Mediterranean Sea and the Atlantic Ocean. It is like this. This is Mediterranean Basin or Mediterranean Sea, and this is Atlantic. So Atlantic is a little bit higher than Mediterranean Sea. So water will generally flow by gravity towards the Mediterranean Sea. So this is amongst the reasons. That geodetic scale of the earth, it means one side being higher or upper than the other one, also causes water to flow. But the second one is prevailing winds. Prevailing winds. Winds blowing on a certain area over a certain period of time causes the surface water to start moving. Third, differences in temperature. You have difference in temperature. It means one parcel of water is going to be warmer than the other one. The other one, which is warmer, will be lighter or less denser than the cold one. So it means water will flow by gravity. And the difference in temperatures causes difference in densities. And of course we have also peel it off, and of course we have difference in salinity. Salinity is the amount of salt in seawater. Difference in salinities, it means the one with higher salinity will be denser than the one with the lower salinity. And another reason could be pressure. Difference in pressure. Say difference in pressure, which of course causes difference in pressure. Difference in pressure. So we can have a big number of reasons causing ocean currents, causing this water to start moving. But in all cases, whatever the reason causing, we have either a cold current or a warm current. But these either warm or cold current, they are divided into 3 plus or minus 1 groups. One, we have the drift current. This is amongst the types of ocean currents. We have the drift current, we have the upwelling currents. And of course, we have the gradient current. Gradient currents. And all these can either be warm or cold. Can either be warm or cold. So when you're talking about drift current, or if you say currents, these ones of course are caused by wind. These are caused by trailing effect of wind blowing, over the surface of the sea for a considerable length of time. So this one will cause the surface water to start moving. The wind is blowing, pushing the upper surface, so it leads to a thick layer of upper surface to start moving in the direction of wind. This is how drift current is caused. So examples of this drift current includes the north equatorial current. We have the south equatorial current. We have North Atlantic current. We have North Pacific current. And we have the Southern Ocean current, which sometimes is known as west wind drift. The two are caused by trade winds. The first two. The rest are caused by westerlies. Some other winds are called westerlies. So these are the examples. But the currents are caused by these reasons. But the earth rotates on its own axis from west to east in 24 hours, producing what is known as Coriolis force. This Coriolis force tends to deflect this kind of currents to the right if you are facing the globe, to the right in the northern hemisphere, and to the left in the southern hemisphere. And that's why you can see a general circulation of ocean currents just above the equator. They are going clockwise above the equator. They're going clockwise, and below the equator they're going anti-clockwise. You can see this kind of circulation because of the Coriolis force deflecting to the right in the northern hemisphere and to the left in the southern hemisphere. So these are some examples of the drift current. This is a kind of amongst the types we discussed about ocean currents. We said we have either drift current or upwelling current or gradient current, plus or minus stream current, because stream current is a product of the gradient current. Stream current. Of course, this one is an example of the Gulf Stream current. So a stream current is like a river in the ocean, So this is the first type. We said drift current, which is caused by the trailing effect of wind blowing over the surface of the sea for a considerable length of time, and of course that water will tend to take the direction of the wind. So the upper surface will be moving in the direction of wind, regardless of the coastline size. When we come to the upwelling, it's slightly different. It is also caused by the wind, but there has to be a long coastline. Wind is blowing away from the coastline. So this wind blowing away from the coastline, it tends to move water from the coast seawards. So there is a gap behind this water. If you remove this water, there is a gap somewhere behind, which needs to be covered. And that gap behind is covered by the water from down. That's why we call upwelling. Water from down coming up to cover the gap, and this is what we call upwelling. Upwelling because it's coming from up, from down going up, from down going up, like that. And this upwelling current, of course, can I clear this side, I think? This upwelling current is a source of nutrition to aquatic organisms like fish, to aquatic organisms like fish, because when coming from down, it comes with the planktons and all other some kind of nutrients to the fish and other living organisms in the water, the aquatic organisms in the water. They get food from that, and that's why wherever there is upwelling current, there is a likelihood of a traffic density of fishing vessels. You can find lots of fishing vessels where there is upwelling current. So it's very important to note that, and of course, and that's why we teach these currents for various reasons. Of course, the main reason being navigational, because when you are navigating, so we say upwelling. The main reason being navigation reason, because we always like to have a good speed so as we can achieve our ETAs. So an adverse current, an opposite current, an opposing current may lead to delays sometimes. If you lose 2 knots in 24, every time you lose 2 knots in every 1 hour, in 24 hours, how much knots? In 1 week, in 2 weeks, if it's a long voyage. So that's why we have a concern, and that's why we have the ocean passages for the world showing all the trend of these currents. We have the routing charts, January to December in all oceans, showing the same. We have the what we call the sailing directions, also telling you when you are crossing this coastline, the currents are behaving like this. You will expect to see 1, 2, 3, 4, and when you drop anchor, there's a tidal stream and all that. So it's very important to know the currents, and that's why now we know the upwelling. Where there is upwelling currents, we are expecting to have a huge traffic of fishing vessels, factory ships, because some other factory ships are also closer to the fishing vessels. When they fish and put in the factory, semi-process and discharge to the shore. So upwelling current, of course, this one is caused by when the wind blows away, it has to be away, blows away from the coastline, causing an outflow of water, from the coast to be replaced by upward movement. This is what we call upwelling. Upward movement means upwelling of water from below the surface, from below the sea surface, up to a depth of about 150 meters. You can see it's too deep. Up to a depth of 150 meters. So in the course of this water coming up, and of course mostly this water will be what? Will be cold, because the cold water is always at the bottom. Once the water is heated, once the water is cooled, it goes down because it becomes much denser. So most of the upwelling currents are cold currents, because it is the cold water which is coming to replace the warm surface water. And when it is coming from down, it comes with the planktons and all other planktons. This one is a plankton. Plankton is food for fish and other aquatic organisms. So fish tend to migrate towards that area with the green pastures. They need to feed as well. So in so doing, it causes a high traffic density wherever there is upwelling current. For example, in the west coast of Africa, here we have Canal Current, and also this is Atlantic Ocean. We have also Benguela Current. It's amongst the upwelling current. And when we come to America, to the American continent, we have on the west coast, we have the California Current coming that way, and we have the Peru Current going up. So these are the upwelling currents. So you expect to find traffic density of fishing vessels along these areas. So even when you're plotting your voyage, you must expect this. That's when I'm getting close to this area, I must find some fishing vessels. This is very important to know. And of course, as we said, mostly they are cold currents because the cold water from down is coming to replace the warm water on the surface. That's why it is called upwelling. And of course, when comes with some food nutrients known as plankton for the fish. And you can find lots of fishing vessels around there. So this is the second type of ocean currents. Now the third one is gradient current. When we say gradient, simply means different in levels. That's why if somebody tells you find gradient, it means find a slope. If you have a triangle, what is this axis and what is that axis? What is this one and what is that one? So if you find a gradient, finding gradient means finding slope. It means changing y over changing x. You get the slope. And of course, this can be equivalent to tangent of that angle if it is theta, tan theta, the slope. So when you're talking about, it means it's difference in levels. When you're talking about gradient current, we are actually talking of difference in levels, and this is what we call geodetic scale of the Earth. But difference in levels could be difference in levels as far as the land is concerned, but could be difference in levels per salinity. This one is more saline than the other one. Difference in levels in density-wise. This one is denser than the other one, or this one is upper than the other one. Just difference in levels causes the gradient current. So this one, again, the example of Mediterranean and Atlantic Ocean comes in because they are of different levels. Because where the position Mediterranean Ocean or Mediterranean Sea is located, it is a landlocked in the first place. So we say gradient current. So these ones are caused by difference in levels. Could be natural slopes. Natural slopes, it means one side being higher than the other. Could be difference in densities. Could be differences in salinity. And the difference in salinity automatically causes difference in densities. Could be differences in temperature. Temperature gradient, density gradient, salinity gradient, slope and whatnot. Could be differences in temperature. And a good example of these two, of course 1, 2, 3, could be 4, is the Atlantic Ocean and the Mediterranean Sea. As I put it before, this is Mediterranean and this is Atlantic, going that direction. And this is Med. This Mediterranean Sea being landlocked, it means it is confined, it is surrounded by lands on both sides. It has higher evaporation rate, and we said amongst the causes of, I didn't put it here, evaporation rate, it was not included, oh sorry, evaporation red. This Mediterranean Sea being landlocked, surrounded by the landmass all around, it has a higher evaporation rate than Atlantic, which is open. Higher evaporation rate causes what? Causes some amount of water vapor to lost. And in fact, if the water vapor is reduced, and a loss in water vapor means a decrease in what? In depth. Because you have amount of water, and you lose some of the water by evaporation. It means now the depth will be decreasing. And if the depth is decreasing, it means this water from Atlantic will be falling by gravity into this one. But that evaporation rate also causes another current. Within this one, it has two currents. There's the upper current, which is an easterly flow from Atlantic through the Gibraltar Strait to the Mediterranean Sea. And there is a down current from the Mediterranean again to the Atlantic. Why? Because after this evaporation, the water becomes more saline. Because it loses amount of water, it becomes more saline. It means there is the amount of salt, the percentage of amount of salt is increased. That makes this water to be much denser than the Atlantic Ocean. And with that gravity, then again, this water will be flowing by its weight to the Atlantic Ocean. So on the upper surface, water is going that way. And on the downside, water is coming the other side. It is coming again through Gibraltar to the Atlantic Ocean. So it's because of the salinity, it's because of higher density caused by high rate of evaporation. So you can find almost these reasons, they come into play. All these ones causing this flow, an easterly flow from Atlantic through Gibraltar into the Mediterranean Sea, and the undercurrent, the subcurrent from Mediterranean due to its high density from Mediterranean to the Atlantic Ocean once again. So this is amongst the gradient current. And the upwelling we discussed before, the upwelling currents, mostly you can find them on the, that's something it was an oversight. You can find the upwelling current. You can find the upwelling currents on the eastern shore of large oceans. Upwelling currents are found or are experienced on the eastern shore of large oceans. For example, as we said before, this is West Africa, we have Canal Current. This is Atlantic Ocean. And we have Benguela Current. This one we say Benguela is upwelling current. Canal is upwelling current. When we come to South America, we have Peru Current, or Humboldt. Peru, or sometimes they call Humboldt current. You can either call it Humboldt or you can call it Peru Current in South America. And of course, when you come to North America, here California Current. California Current. There is Pacific Ocean on this side, so the eastern shore of Pacific is this one here. Although it is on the western part of America, this is on the western part of South America, but it is on the eastern shore of the Pacific Ocean, because we have the Pacific Ocean far on the west. So this one on the east side and this one on the east side. As well in Africa, we have Atlantic Ocean here. This is the Atlantic Ocean, the whole of this. And the shore here is on the eastern side of the Atlantic Ocean. So you can find them on the eastern shores of large oceans. Eastern shore of Atlantic Ocean, eastern shore of Pacific Ocean and other large oceans. You can find the upwelling currents. And of course, you must expect a fleet of fishing vessels. That is the important point which I had to cement on regarding the upwelling currents. So now after discussing this one, now we come to the to the warm and cold currents. When a current moves and meets an obstacle, it is caused by a current moving meets an obstacle. Now that obstacle could be another current, could be a counter current, could be a land, anything it meets. So this obstruction causes it to change its direction. That obstruction, for example, this is the current coming that direction, meeting something here. So it changes the direction or down that side or this side. So this one, after changing the direction, it creates a stream current. So either it meets a land or another stream current. And like, for example, if you look at the Gulf Stream, there is a north equatorial current setting westerly. So when it strikes near Caribbean, when it strikes the land near Caribbean, it starts forming the Gulf Stream. It starts forming the Gulf Stream because this north equatorial current coming, striking the coast, the east coast of Central America, deflected again back to the sea, forming Gulf Stream. And this Gulf Stream will continue. Upon meeting with the Canary current and the Portugal current, it will split again, forming the North Atlantic current and another current coming downwards in the west coast of Africa. So most of them are like that. So an example of this is a Gulf Stream, as I gave you an example. It's produced by the North Equatorial current, which is setting westerly, because along the equator we have a South Equatorial current going that direction. And we have a North Equatorial current going that direction. And in between here, we have an equatorial counter current going easterly. But these two, this South Equatorial current and the North Equatorial current, when they get into the land, they are deflected by Coriolis force. The North Equatorial current will go to the right in the northern hemisphere, and this one will go to the left in the southern hemisphere. So in this case, let's see how the general circulation is at a quick glance, so as to cement what we are discussing, to have an image of what we are discussing. Very unfortunately, then I have to rub all this because I just want to put a world map, if I can remember, if I can put it well, because it needs some art, and unfortunately I'm not an artist, but at least to give you a picture of what is going on the globe. This is very important to know this as navigators. Let's start with just a simple Africa. Around there, with its Madagascar almost there, with its Australia almost there, and we have, say, South America almost there, and we have the North America that side. Not good at taste. And we have, of course, we have the Greenland almost around here. The Greenland, the Iceland, the Baffin Bay here, Baffinland, and we have the other end could be. I just want to put an example for some main circulations, and we have. This is our equator, and we have the Indian subcontinent maybe around here. Indian subcontinent with the Sri Lanka. So the main circulation is, we said, there is this what we call North Equatorial current. This will continue like this, Again, getting here, it splits. And we have the south equatorial current. Upon getting here, it splits, some going that side, some coming this way. To form Mozambique current, and then Agulhas current, and then Benguela. And we have the Falkland current there, we have the Brazilian current down there, we have the Peru current, and then we have the California current coming down. We have the Gulf Stream turning here, going that side. And of course we have Gibraltar here. And no, that one was wrong. This one was too far. This one was on Asia. Gibraltar there, and we have Greenland around there with the Iceland there. Almost. So we have this one is North Equatorial Current. And we have this one, South Equatorial Current. And we have another current down here, going all the way below Africa to Australia. Of course, we have the East Australian current and we have the West Australian current. And this goes all the way again upon, this side is on the other side. So upon getting here, this again is deflected upwards to form South Equatorial current. But in between there is an equatorial countercurrent. Equatorial countercurrent. Counter means going opposite. Equatorial countercurrent going the other side. Likewise here we have the South Equatorial current and north. South and north, south, north, south, north. And we have a countercurrent going opposite on both sides. Upon getting here, it forms Guinea current. We have the Canary current here. We have the what we call Portuguese current there. And of course, this is the Gulf Stream. Gulf Stream, Peru and California. Now on the Iceland, we have one current going that direction, and we have another East Greenland current turning to West Greenland current, and we have the Baffin Island of Baffin Bay, where the Labrador current passes on this side, coming downwards. So what we are trying to say, this is the question. This one is Brazilian current. Brazilian current, and this one is Falkland current. And of course, upon meeting, this Brazilian current will be deflected, joining this one again, going there. Part of which will form Benguela current, and part of which will continue with the southern, we call it Southern Ocean current, or sometimes we say west wind drift current. West wind drift current. Now this is just part of some currents, just to show you how they are deflected. So when we're talking about the warm and cold currents, any current originating from the equator going to the higher latitudes is warm current. Any current originating from the equator or from lower latitudes to higher latitudes is warm current. And any current originating from higher latitudes to low latitudes, so either coming to the equator, is a cold current, because at higher latitudes we are expecting to have extremely low temperatures in higher latitudes, whether in south or north, and that's why this Southern Ocean current, it's the one, this is the ice limit, it's the one also taking the icebergs all around to that side. The same likewise to this current. The icebergs coming from between Iceland and Greenland, they're coming down here, taken by this East Greenland current. They're taken up with the Western Greenland current. Again, the Labrador current takes them down. When it meets the Gulf Stream, this one is warmer. It's a warm current, Gulf Stream, as you can see. It is going up. It means originating from the equator. It's going out from lower latitudes. It's going up. When it meets around here, when it meets the Labrador current, this one is cold. When it meets, it moderates, and of course it gets the icebergs melting. And of course, including in the reasons for formation of ocean currents also, melting of ice or snow. You can increase it, you can add it on the 8th point, because we said the evaporation rate, and then the 8th point is melting of ice or snow also causes ocean current, because when it melts, it forms water which is less saline than the surrounding one, and then it moderates to make it moving. So any current originating from low latitude to higher latitude is warm current, and any current originating from higher latitudes to low latitudes is cold current. And for example, you can have an example of most of the warm currents are on the western shores of the large oceans. Most of the warm currents are on the western shores of large currents. For example, here Mozambique current is warm. Brazilian current is warm. Brazilian current is on the western shore of Atlantic Ocean, and the Mozambique current is on the western shore of Indian Ocean. So that is just like we saw on the upwelling currents, they are found on the eastern shores of the large oceans. Now the warm currents are found on the western shores of large oceans. For example, the Mozambique current is warm and is found on the western shore of the Indian Ocean, and the Brazilian current is warm and is found on the western shore of Atlantic Ocean. Of course, the Gulf Stream also is found on the western shore of Atlantic Ocean, North Atlantic Ocean. So this is how we can see. And of course, this one is cold because it was on the eastern coast or eastern shore of the Pacific Ocean. Likewise, this one is cold because it's on the eastern coast of Pacific Ocean. Some other currents, for example, because I cannot put it well, for example, Japan Sea, you have this Japan Island, and this is Japan Sea. This is Japan Sea. You have Riemann current going that direction. Riemann current going that direction. And we have Tsushima Shio. Tsushima Shio. This one here. This is Tsushima Shio going that direction. You have Kuroshio here. And of course you have this Oyashio. This is Oyashio. And Kuroshio is here. Kuroshio. Going that direction. So now this is Japan Sea. Now you can judge, is this warm current or cold current? Just know if this is north, this is east, this is west, and this is south. So this is Japan. This is Japan Sea. Which side is the eastern part of Japan Sea? This side or that side? Which side is eastern? If you look at this compass, is this the eastern part of this Japan Sea, assuming this is the sea? Which side is the eastern? This is the eastern, and that was the western. So if this is the eastern, what could this current be? Is it a warm current or cold current? Warm current. So that's an example of what we actually discuss about the ocean currents. So there is a number of examples of warm currents, like the Gulf Stream itself is warm current. Mozambique current is warm current. Brazilian current, warm current. North Atlantic current is warm current, as we've been discussing here, going that direction. This is North Atlantic current, produced by the Gulf Stream. And the Gulf Stream is produced by the North Equatorial current. So each current is produced by another current. Like for example, this South Equatorial current comes on the Madagascar here on tip of Madagascar. It splits. Some coming this way, some goes that direction, forming Mozambique current. And the Mozambique current produces Agulhas current in South Africa. And Agulhas produces the Benguela, which is also substantiated by the South Equatorial current coming from, after striking the east coast of South America, coming this way, meeting with the Agulhas current to form Benguela current, going upward. And this Benguela current also forms the South Equatorial current. It's a continuation like this. So those are the examples of warm current. We have also Agulhas, Kuroshio, this one here, Kuroshio current in the east coast of Japan. And we have the East Australian current, this one here. This is Australia. This is Australia, this is West Australian current, and this is East Australian current. We have the Alaskan current. Of course, Alaska now is on North America. Some of them is also amongst. And of course, we have the Norwegian current. When we come to the cold currents, we have the Baffin, we have the Labrador current. This one here, Labrador. This one is West Greenland current. This one is Labrador coming down. Of course, it will meet this one here, and it will meet the two currents here. And this one is the East Greenland current. We have another Baffinland. Baffinland is between this one Greenland, and this is Baffinland. So there is a Davis, or they call Davis or Baffin current. It's also amongst the cold currents. We have the Kamchatka, we have Benguela, Labrador, Portuguese, Canary, Falkland, Peru, West Australian, Oyashio, California. All these are cold currents, and of course they are all found on the eastern shores of major oceans. This is Pacific Ocean on the eastern shore. This is California and Peru. This is Indian Ocean on the eastern shore. There is this one, Mozambique current. You have the East African current. All these are the warm currents. I think for today the period is over. We've been discussing about the ocean currents, the types of current. We said about drift current, upwelling current, and the gradient current, plus the stream current. And we discussed the cold current. We have the warm and cold currents. Warm currents are always found on the eastern shores of large oceans, like the Mozambique current and Brazilian current. Mozambique on the eastern, on the western Indian Ocean, and of course the Brazilian current on the western of Atlantic Ocean. We have the cold currents as well, like California and Peru, which are found on the eastern shores of the large oceans. That one is on the eastern shore of Pacific. Then you have the Benguela and Canary Islands, Canary currents, which are found on the eastern shore of Atlantic Ocean. And we have, of course, the Kuroshio, Oyashio in Japan, and the Tsushima Shio, and the Lehman current also going downstream. We have the East Australian current, and of course the West Australian current. We have the Southern Ocean current, which takes, of course, which is moving closer to the ice limits, and it is the one taking the icebergs on the southern part of our globe. And this comes to the end of our period for today. My name once again is Captain Konsi Mgawe from Azam Marine. Thanks a lot, and don't forget to follow and subscribe. Bye bye. Safiri salama na merikebu.
Ndugu mtazamaji wa kipindi chetu cha Safiri Salama na Merikebu, huu ndio mwisho wa kipindi chetu safi na pendwa cha Safiri Salama na Merikebu. Lakini mtazamaji wetu, ni matumaini yetu umefurahi sana na somo letu la leo la kuhusiana na ocean currents. Lakini ndugu mtazamaji, ni mambo gani basi alizungumzia mtaalamu wetu, mwalimu wetu Captain? Alizungumzia maana halisi kwanza ya ocean currents. Uliona baada ya pale akazungumzia tena causes za ocean currents, akazungumzia na uliziona pale. Lakini sio tu, akazungumzia Benguela currents, akazungumzia warm currents, akazungumzia cold currents, lakini akazungumzia vitu vingi na vingi kuhusiana na mambo ya currents. Kwa ujumla umeona hali halisi ya currents. Matumaini yetu mtazamaji umefurahi sana, hasa kwa wale ambao ni mabaharia au maofisa ambao wanasomea masuala ya uongozaji wa vyombo baharini. Basi ni somo zuri kwao na ni kipengele kizuri sana, na wale pia wanafunzi wanaosoma masomo haya ya masuala ya bahari. Usisahau kubonyeza subscribe na alama kengele ili uweze kupata mwendelezo wa mara kwa mara wa vipindi vyetu. Lakini mtazamaji wa kipindi chetu, tunashukuru sana DMY, Dar es Salaam Maritime Institute, lakini vile vile tunaishukuru TASAKI, tunashukuru ZMY na mamlaka zingine, taasisi zingine zinazosaidia kusupport kipindi chetu kiweze kuendelea siku hadi siku. Ulikuwa na mimi Captain Josiah Mwakibuja kutoka Joe Limited Company.